Hey guys, today we are actually going to create a player class so that we can actually interact with our world a little bit and control a little blue ninja as he runs across the screen. Hey guys, and welcome to your next tutorial. Today we are going to be adding a player class to our ninja platformer that will allow us to run around and jump and smash into boxes and things like that. But first thing we want to do today is fix a small bug that we've had in the game. It's a really easy bug to fix. I'll go ahead and run it and show you what's happening. If we try to quit by clicking the X button at the top right hand corner, we're going to get a crash. It's going to say access reading violation at OX fee. Now this fee is a Microsoft basically error code that indicates freed heap memory, and if we hit break it'll take us to the offending line of code. This is happening in screenList.destroy, and our call stack says it's happening in the destructor for screenList. The problem is we're trying to destroy a screen that's already been freed. Its memory's already been freed because it doesn't live, the screen doesn't live in ScreenList. We have a pointer to it in ScreenList, but we actually store the screen's memory itself in the app, and we add it in add screens. If we go to app.cpp, you'll see where that is. We have this gameplay screen, this unique pointer. This is the actual screen's memory. It's living in app, and app is getting destroyed before we call the destructor for the screen list, and that's what's causing this error. So all we need to do to fix this, it's actually really simple, is we need to go into let's see, the iMainGame.cpp into this onSDL event, and whenever we get the SDL quit event, instead of setting im_is_running as to false, we need to call our cleanup function, this exit game function, that does all the destruction and it sets im_running to false. And if we do this, we're not going to be forgetting to destroy the screen list when we exit, and we won't get that crash anymore. And I'll go ahead and show you that. So now when I run it and I hit X, it quits without crashing, and that's what we want. Now let's go ahead and get started on our player class. Let's go ahead and go to Solution Explorer and create, not in ballgame, in the Ninja Platformer, we're going to add a class, and we'll just call this player. Player equals. I just got a new keyboard today. I have a cheap $9 keyboard while I'm waiting for a brand new keyword to come in because my other one just broke. So you're probably going to be seeing me do a lot of mistypes today. Okay, so our player class is going to allow input and things like that. It's going to be able to be rendered. Let's do a void draw, and let's do a void update. And we'll likely need to pass some things into this. Now we're also going to need some private variables, and just like in our box class where we have the body and the fixtures, we're going to be doing this for our player too. He's going to have a physics object, but his physics object is going to be a little bit different, and that's okay. So we're going to grab this. We'll grab dimensions as well. In fact, we can just give the player a box class internally, and then we can use that box class. So let's go ahead and do that. We'll use a little bit of composition here. We're going to say box collision box. That'll be his box. And then we'll do a, let's see, we'll return a const box reference get box, and that will return the box. Const, this will be our little getter function. Oh, here we go. My backspace key is in a different place, so this is going to be very difficult. Const, and then we'll do return collision box. There we go, and it likes to put that on 2 lines, but I don't like that. Oop, and I hit the insert key. Return collision box. So now we can get this box, but of course we need to include box at the top to even have access to that. Include box.h. Now the update function is going to be what allows the player to move around, and then we can, if we need to get the box to do any specific collision stuff, we can do that, but we'll probably be handling all the collision specifics in update. Now what we want to do is we want to create a player and then use him to walk around. So let's go into main game and give ourselves a player. Sorry, not main game. We need to go into gameplay screen. Let me close some of these windows that we don't need anymore so we don't get too confused clicking around here. Don't need that, and we'll keep those. Alright, so let's include player up here. And we'll create ourselves a player. So we're going to say, we'll put it right here, player player. And player is going to need an init function, of course, so void init. You could also use the constructor as always, but we're just going to use the init function so that we don't have to construct him right away, and we can keep him as a little static object in the class. And now an onEntry is where we're going to actually init that player. So we'll go into onEntry. And we're going to call player.init down here. Init player. Init. There we go. And this is going to set up all of the physics stuff for player. Now if we go into the init for player, let's go ahead and implement all these methods. I'm going to cheat and use Visual Assist. If it will let me, create method implementations. Okay. And go into player.cpp. And we have 2 constructors now. Whoops. All right. So in the player.init method, we're going to call mCollisionBox.init, and it's going to want some stuff. It's going to need the world, it's going to need position, dimensions, and color, and we'll just pass all of this into player.init and sort of just pass it through. So I'm going to grab this whole thing from box.init and pass it through just like we do with the regular box. So let's copy that, those set of parameters into player.init, and then we're just going to pass them through here. World, position, dimensions, color. And that'll set up our collision box for the player. Now it's going to be a little different. For the player, unlike these boxes that we have that have full angle, full dynamic motion, oops, here we go. Player init does not take 0 arguments. Go ahead and pass these in so I can make it build. We'll say world, and then what do we need? For the position, let's see, where are our other things distributed at? Let's go ahead and make the player pretty much above everything. We'll set him at X position 0, Y position 30. So B2 or GLM vec2, X position is 0 and Y position is 30, and then he should just kind of fall. And then for the dimensions, let's see, let's go ahead and do 1 meter tall and 0.5 meters wide. Actually, we'll do 2 meters tall, that makes a lot more sense. GLM vec2, so the width is going to be, we'll say actually, yeah, we'll do 0.5 and 2.0f. We can change that later if we feel like it. And last thing is the color, so we're going to say Benjin color RGBA8, and this will be just a white color. We'll just use whatever the default texture color is for now, for whatever texture we decide to use. Now this should be a pointer to b2world. Actually, it should be b2world.get since we're using a unique pointer. There we go. And now we can initialize the player. Let's go ahead and run it. And as you can see, these boxes, they rotate, but we don't want the player to rotate. We're going to need to change the way the player works a little bit. And to do that, we're just going to use another property when we actually initialize the box for the player. So let's go into mCollisionBox.init, and the actual parameter that we want to set is this bodyDef.fixed rotation. So we need to pass in an additional boolean into box init that will handle that. So let's say bool fixed rotation, and we've got to put that in the header file as well, just like that. And now we can use that. So we can say bodyDef.fixed rotation equals fixed rotation. There we go. And if we don't want to have to change the call site, we could even make this a default parameter that's defaulted to false, but I'll just go ahead and change it since it's fairly easy. So for mPlayer.init, the fixed rotation is going to be true since we don't want him to rotate. Whereas for all the other boxes which we create here, we want the fixed rotation to be false. There we go. Now we need to actually render the player like we're rendering the boxes, and we'll just call a draw function for the actual player. And really we should have a draw function for these boxes too. So let's go ahead and do that while we're at it. So for the body, we are going to have a draw function, let's say, or sorry, for the box, and we'll put that below init, void draw. Now remember, we could also have separate renderers like we did in the ball game, so that we could have lots of different types of rendering that we can easily swap out, but for now I'm just going to go the easy route and just have a draw function. So we need a sprite batch, so Benjin sprite batch, sprite batch. And we also need to pass in whatever texture it's going to use, and really the box should hold the texture. So let's store the texture here. We're going to say Benjin GL texture M texture. Doing a little bit of refactoring while we're doing this, since the previous tutorial was just sort of a little introduction to Box Studio. We need to kind of clean up the code today. Oops, this has an extra space. So include Benjin sprite batch, and I could use a forward declaration if I was worrying about compile times. And we need to include Benjin GL texture.h as well. There we go. Now we can render that, so we don't need to pass in the texture either. So let's go ahead and grab this and put it in the CPP file and implement that. And this will just be a little bit of copy paste. It should be pretty easy. Benjin draw. And now if we go to gameplayscreen.cpp, we're just going to grab all of this and move it. And then we can just call b.draw and pass in mSpriteBatch. Let's see, go into box.cpp, paste it here. Now let's see, we're going to have an error here because this should be just sprite batch, not mSpriteBatch. And since we know we're going to be using a static object, instead of passing a pointer, we can just pass a reference, just like that. Reference sprite batch. Just make things a little easier. References are generally safer than pointers when you can use them. Alright, so now instead of b.getBody, we can just call getBody, or we can just call mBody, since we are actually inside the box now. So let's do that. Let's make it a little cleaner. We can say mBody, reduces our code size a little bit, mBody, and then mDimensions here. That's about the same size, just a few characters shorter, but I think it looks a little cleaner. There we go. And now we can draw this from the inside. The only thing we need now is instead of b.getColor, we just call getColor or mColor. We'll use mColor. And instead of b.getBody, getAngle, we're just going to say mBody, getAngle. And let's see what else. mTextureID is correct. We are going to be passing in the texture when we initialize the box, so let's do that as well. Before color, we'll say glTexture, texture, and we'll pass that in. So we can say mTexture equals texture here. Easy as pie. And this should actually be Benjin glTexture, texture. And let's put this in the header file, and then we should be good to go. We'll make sure everything works the same way. Now we need to go to, let's see, gameplay screen. There we go. This no longer is giving us an error. However, we're going to get some errors up here when we try to initialize the boxes because we're not passing in the texture correctly. Let's go ahead and load the texture a little higher so we can actually pass it in. We'll load it right before we create the boxes. And then we'll just pass it in before the color, just like that. So now our boxes are kind of self-contained. They have their own draw function. We need to make sure we call a draw function for the player as well. Let's see, player.h. The draw function needs to take the sprite batch. So Benjin sprite batch reference sprite batch. And we'll include sprite batch up here. Batch.h. I don't know why it doesn't like to autocomplete that. And we also need to pass in the texture into the init function, just like we did for the box, because remember we're just doing sort of a pass-through thing. glTexture, texture. So let's include texture as well. glTexture.h. And I've got to put that in the CPP file and pass that through for both of the draw and for the, oops, that for some reason took me to box init. We want to go to player init. So pass texture. And for the draw function, we need to copy that sprite batch and then just call box.draw. So right now the player is just a wrapper around the box, but the player is going to have his own update logic that will allow us to move around as well. Okay, now let's check that everything works. We might get a compile error here, but yes we are, because we forgot to pass in the texture to player init. Now for now I'm just going to use the same texture, but we'll be using a different texture. So let's go ahead and pass it in here. Now let's run it. Okay, so the boxes are behaving the same way. Now the player isn't doing anything. We can't see the player falling or anything like that. Let's go ahead and break out of this. Now the reason we aren't seeing the player falling is that we never actually called the draw function for the player. So let's go ahead and do that in the gameplay screen. So if we go down here to draw, we're just going to draw him right after the boxes. So we're going to call mPlayer.draw, and then we're going to call it with mSpriteBatch. Now we should see a little brick box falling that is fixed in its rotation. And as you can see, he's probably a little bit too thin. Let's make him a little thicker. Let's make him 1 meter wide. That'll make a little bit more sense. So let's go down here. We're going to call in the init function, instead of 0.5, let's do 1.0 and see how that looks. Now he's going to fall again. And there he is. So there he is in the middle. My mouse is hovering over him right now. And we need to be able to control him, make him move around, and allow him to jump and kind of push these boxes around and things like that. And to do that, we're going to mess around with the update function. But before we do that, let's actually make the player character a little bit more attractive. Let's go ahead and actually use the texture that we have for the ninja. Now, if I open up our assets folder here, and let me drag it down so you can see. In Ninja Platformer Assets, we have this blue ninja.png. I'm just going to open it in Paint. And we have, it's a 10 by 2 little texture, and you can see in the credits.txt where I got it from. I just got it from Open Game Art. This was made by KZR. So let's go ahead and close that. Now what we want to do is we want to eventually we're going to be using animation, but for now in this tutorial I'm not going to teach you animation. We're just going to try to extract a single frame of this animation, and let's use the bottom left one where he's just standing there. And it's not going to look very good, but it's going to look better than our brick texture. So let's go ahead and do that. So if we look at the coordinates here, the x coordinate, if we were saying that the top here is 0, the x, or sorry, if the y coordinate is 0 here at the top, then the y coordinate is going to be 0.5 for our UV coordinates, and the x coordinate is going to be 0, and then the width of the x is going to be 0.1 since we have 10 frames, and 1 divided by 10 is 0.1, and the y dimension is going to be 0.5, which is half of the texture. So let's try to do that. Let's try to load this blue ninja.png, and then let's use that to set up our little player texture and then render him a little bit better. So now instead of passing in the texture, I'm going to actually load the texture in player.init. So let's go ahead and go into player.init and change this. So we're going to get rid of this Benjin texture call here, and we'll do the same in the header file, get rid of that. Now in the actual init function, we're going to use our resource manager like we did before to load a texture. So let's include Benjin resource manager.h. That'll let us load a texture in. And out of the spirit of laziness, I'm just going to copy paste this texture load call and then simply change the file path. So here we go. We're going to say gl int, I believe, texture. No, sorry, gl texture Benjin gl texture texture equals this, and instead of bricks top, we're going to say, and I forgot what it was, it is blue ninja, so blue ninja.png. Now when we actually set up the collision box, it's going to try to render the whole thing, and I'll show you what that looks like. It's going to render the entire sprite sheet in this little box, and it's going to look terrible. And it looks like we can't even see it really. I think I can kind of see it, but it's so small on this dark background that it's really hard to tell. So let's make sure that we are making the ninja the correct size. Let's make sure he's using just a single frame of that animation. If we go into collisionbox.init, when we call draw here, it's always using the same UV rectangle, so we should also be able to pass in a UV rectangle here. But we should make it optional because most of the time you're going to be just using the default UV rectangle, which is this one right here, this 0011. So let's say glm vec4 UV rect equals this. Now in the CPP file, you don't actually declare this again or you'll get an error. In the CPP file, we want to actually comment it out. Now Visual Assist lets me do this where I can do the C style comment all around it. You'll have to manually do that. Now we need to actually set that up in the header file as well. Now this line of code is getting way too long. So let's go ahead and break this into a few lines. Let's hit enter there, and how about we break this up here as well, and here. I like that. That looks kind of bad, but there. And we can do the same thing in the CPP file, just to keep it a little bit cleaner than it is. And I don't remember exactly how I broke this up, but I think it looked a little bit like this. There. Now they are, I believe, you know what, let's just make everything on its own line, because that looks fine too. There we go. Now it's much easier to read, since it's just on a single vertical column. If you have a small screen, it's really beneficial to do it this way. Really, you're supposed to keep it within 80 characters. Okay, so that's the default UV rect. Let's go ahead and store that. We're going to say glm vec4 muv rect. And then we're going to set this in the init function. So here we go. In the init, we'll say muv rect equals UV rect, like that. And then finally, down here, instead of making our UV rect with the default one here, we're going to pass UV rect. Now, since we made it a default parameter, we don't have to change anything right now. It'll still run exactly the same as it did before if we hit the run button, as you can see. But our player, of course, is still using the crappy default texture coordinates that we don't want to use. So let's go ahead and change that. If we go back into player, here at the end, we're going to change the UV rect. We'll say glm vec4. Now, I'm probably going to get this wrong the first time. So the x we're going to say is definitely 0.0f. Now the y I'm pretty sure we're saying is 0.5f. The width is going to be 0.1f, and the height is going to be 0.5f. Now let's see if I was right. Usually I get it kind of upside down because OpenGL kind of flips the texture. Now let's see, there is our ninja, and we do have a sprite, but it's not the right one. Let's see, which one are we using? We are using this one right here instead of the one below it. So I did get the y coordinate flipped like I always do. So instead, let's try y0 and then see if that fixes it. And we also need to widen our collision box a little bit. There we go. Now our little guy is standing there. He's a little bit skinny, so I'm going to make his collision box a little bit wider. Now in the future, what we really need to do is make it so that his collision box is smaller than his rendered texture. Because as you can see, his rendered texture is just this big, but his collision box is way out here. So really, let's just keep him skinny for now. Oops, and I messed that up. Let's keep him skinny, and in the next few tutorials, we can switch it so that we have a separate collision box and render box for the player. Alright, now let's go ahead and do some character movement. And to do that, we're going to use the update function. Now what we want to do is we want to actually pass in the input manager that we are storing in the app so that we can check the key presses and then apply some forces to the player and change his velocity. So to do that, let's go ahead and see where we are storing that input manager, and it's actually stored, I believe, in iMainGame. And here we go, we have an input manager, but unfortunately we can't access it. We never actually exposed this. So let's write ourselves a getter function. We're going to say input manager. Actually, since we're going to pretty much be completely exposing this, let's just turn this into a public variable, which public variables are sometimes bad, sometimes good. Usually they're bad. If you need to do any kind of logging, you should always do getters and setters, but if you're not planning on doing logging or doing any special wrapping stuff, and you just need something quick, you can absolutely use a public variable, and it's often cleaner than using a getter and a setter since it's much less code to type. You really have to use your own discretion with that. People will give you differing opinions on when you should use public variables or not. Okay, so I'm sure we're going to get some errors now because the name of this is different. So let's go into onSDL event, and here we go. This would just be input manager, no longer m underscore, since it's no longer a private member variable. Just fix all that. And now we can access input manager easily. So what we're going to do is in the update function, we're going to pass in an input manager, and we're going to say input manager, like that. And I believe input manager is it's in input manager.h, so let's do that. Really, that should be a part of Bingen. I'm not sure why it's not, but it isn't. Where are we? What are we doing? We need to include input manager. So now we can pass that in and query for the key presses. Oh, right, it is in Bingen. But for some reason, it's not in the Bingen namespace. So, or it is in the Bingen namespace because iMainGame is in Bingen. Look at me making trivial mistakes. Let's copy this now to the CPP file. So now we can pass in the input manager and use it to move our player around. So let's try just doing the A key and the D key for left and right movement. And to do that, what we're going to do is we're going to say if input manager dot is key down. Now remember the difference between is key down and is key pressed is key pressed will only check if you just pressed the key, whereas is key down will just check if the key is pressed at all, if it's down. And we're going to check with SDLKA, this is the left arrow, basically, or the left movement control. You can also use SDL key left arrow or something like that. Now we're getting an error here because we need to actually include SDL. Include SDL, SDL.h. Now if we were making a legit game engine, which we're not, we wouldn't be forcing the users of our library to include SDL. Instead, we would have our own wrapper that has our own key codes and things like that. But we're trying to make just a very small, basic engine here with as little work as possible. Else if input manager dot is key down SDLK D. There we go. Now we need to actually apply some forces. And to do that, we're going to modify the body a little bit. The collision body of our box. Because remember, we have a collision box, and that's what we're going to be moving around. So let's go ahead and call mCollisionBox.getBody. That will return us the body. And then all we have to do, it's really simple, is we call arrow apply force to center. And this will apply a force. Now it needs a vector for the amount of force. So we're going to say b2 vec2. This will be the force. Now since we're going left, we need a left force. Let's do negative 100 and see how that works. And there's going to be no y force. And then this bool wake just says if it's going to wake up the object. You can make objects go to sleep, and that'll change how they are affected by physics. Often I think they're not affected by physics if they're asleep. We'll just set this to true. Don't really need to worry about that too much. And let's just copy this. If we're going to the right, we're going to do positive 100. Now, this is going to look terrible, but let's see what it looks like. Let's go ahead and run it. Oh, of course, we actually have to call update or nothing's going to happen. And we have an error because input manager is not im underscore. We need to call the update function, so let's go to gameplay screen update, which happens here. And what we're going to do is we're going to call imPlayer.update, and we're going to pass in im underscore game arrow input manager. There we go, and now we can run it. And we should be able to control that player. And I think he's going to move really fast, but let's see. Okay, so here's the player, and there you go. I am pressing right, and he goes to the right. I press left, and he goes to the left. Now, gravity is really low, and we also can't jump, so that's a problem. So let's go ahead and first make gravity a little bit higher, and then let's make it so we can actually jump, because otherwise I just get stuck between these boxes, and I can kind of knock them back and forth, but that's all I can do. So back to the graphics tutorials gameplay screen thingy. Let's go ahead and change physics a little bit. So here we have gravity. Instead of negative 9.81, let's do negative 14. Let's see how that looks. And let's also add some jumping. Now jumping is a little bit harder. Let's go ahead and go into player, and I'll show you how we do that. So what we need to do is we need to actually check when the player is standing on the ground. And unfortunately, there's no simple is standing on ground method or anything like that with the collision boxes. So we're going to have to write a little bit of code here to detect when the player is standing on a ground or on the box or something like that. And to do that, what we're going to be doing is we're going to be looping through all of the contact points of our player. Every time he's touching something, it's going to have a contact point stored in our body, and we can use that to actually determine if that contact point is where our feet are, and if it is where our feet are, then we can jump. So let's go ahead and try that. So the way we do that is we need to loop through all of the different contact points that our body has, and to do that we do this. We do for, and we need to use a special type of iterator called a B2 contact edge, and this is going to be basically an edge between two contact points. And we're going to say star, we'll call it CE, contact edge, equals, and we're going to just call im collision box dot get body. And since we don't want to keep calling get body all the time, let's store a local variable for that. So we're going to call, we'll say b2 body star body equals get body. It's always a nice little trick. Make our code a little bit smaller, more easier to read. All right, so now contact edge equals body arrow get contact list. And this is actually a linked list. It's sort of like just it's pretty much the same as a regular STD list, but you call the iteration a little bit differently. And we're going to loop for as long as CE is not equal to null pointer. Once we reach the end of the list, CE will be equal to null pointer. And the iteration, instead of CE++, we just call CE equals CE arrow next. And that's how linked lists work. And internally, an STD list does pretty much this exact thing. Okay, so let's go ahead and put a comment. Loop through all the contact points. Now we need to get the actual point on the object that we're colliding with. So let's get that. We're going to call B2 contact star. And we'll call this just contact point, or let's just call it C to keep it small. Equals CE arrow contact. And this is the actual point on the body that we're colliding with that is touching our contact point. Or sorry, that's touching our player. Now we need to figure out if this contact point is actually below the player, as in if it's near his feet. And if it's near his feet, then we can jump. So first thing we need to do is see if the contact is even touching. So we're going to say C arrow is touching. So this is basically just going to return a Boolean if the contact is touching us. There we go. And next thing we want to do is we have to use this special class called a B2 world manifold. And what this does is it basically stores all of the different contact points of this specific edge, this specific contact. So let's go ahead and use that. We're going to call B2 world manifold. And if I'm going a little too fast for you, if you forget any of this, remember to check the documentation on the Box2D website because it goes through all of this stuff. Let's see, B2 world manifold. And what we need to do is fill this manifold, because right now I've just created a manifold and we have to actually fill it with the information, with the actual manifold of our contact point. And to do that we call C arrow get world manifold, and we pass in a pointer to that local manifold. So this temporary little manifold here just gets filled with data. There we go. And next what we need to do is actually check if it's below us. Check if the points are below. So we're going to say bool below equals true. And we need to loop through the contact points. So there's going to be actually 2 contact points for all convex shapes. Let's do a little for loop here. We're going to say for int I equals 0. I is less than, and we could type 2, but the safer thing to do is to type B2 underscore, B2 underscore, I believe it's max manifold points, I++. And if I mouse over this, I don't know if it'll show in the video, but it's actually defined as 2. This is just a constant integer, basically, that's the number 2. Now we get to actually loop through the contact points. So what we can do is we can say if manifold dot points dot y is less than manifold points I dot y is less than, and here's where we actually use our body again. We're going to say body get position dot y minus, and here's where we need to actually subtract our dimensions because we need to check the bottom. The position is just at the very center of our box. We need to check the bottom of our box, so we need to do a subtraction for half the dimensions. So minus m dimensions, and actually it should be m, it should be body, no, it should be m collision box dot get dimensions dot y divided by 2.0f. And just so we have a little bit of wiggle room, I'm going to add 0.01f. So if it is there, then what we can do is we can say below equals true. Now below is already equal true, so let's actually set below equal to false, and then say below equals true here. And now after this for loop, after we've checked all of this, we can say if below, then what we can do is we can say if it's below, then we can now check for a jump. So we can jump. And to do that, we're just going to say if input manager dot is key down, and the key down is going to be SDLK. I'll use the W key to jump. And actually, not is key down, we want is key pressed. We don't want it to where you can just hold down the key and just bounce up and down, because that's not too good. Is key pressed. If this happens, we can jump. So let's say SCDC out, and let's do can jump. Let's just test this for now. We'll do space. And I can't do STDC out because I don't have IOStream. Now let's run it and see what happens. We should not get a crash. We should get can jump whenever we're standing on something solid. And it looks like we're not getting it. I think I messed up the logic. Give me just 1 second. That's a false alarm. We actually don't have a bug. I just was doing the can jump C out inside the W instead of outside. So if we put it outside and we run it, now you'll see here, once we land on the ground, it says can jump because we're standing on top of something, so we should be able to jump. Now let's actually make ourselves jump with the W key. So let's get rid of that C out statement. Now what we need to do is we need to apply a force upward. However, we're not going to be calling apply force to center anymore. What a force is the force over time. So this is the amount of force that's going to be happening per second. It's not an instantaneous force. You have to call this every frame for a full second to actually apply a 100, I guess this is newtons, I don't know, a 100 force. But what we can do is we can use a separate function that will apply an instant force, an instantaneous velocity upwards, and that is the apply impulse function. So let's try that. We're going to say body arrow apply linear impulse. Now the actual impulse is going to be b2 vec2. For the X, it's just going to be 0 since we're jumping upward. For the Y, let's see, let's try 10 and see how that does. Now for the point, we're going to call, we can't unfortunately call apply linear impulse to center, so we just have to give it the center point. It doesn't particularly matter too much since our body is has a fixed rotation anyways, but let's just go ahead and give it 0. 0.0 F. And for wake, again, we'll just set it to true. So now we should be able to jump. Let's go ahead and try. I'm going to run it. And our little guy's falling. And he's standing on something, so if I press W, he jumps. And it's a very, very little jump. And if I keep pressing W as fast as I can, he doesn't jump multiple times. He only jumps when he's touching the ground. But 10 is much too small. 10 is a very, very baby jump. Let's try 100. So let's go back to the game. And let's change this to an impulse of 100. There we go. And now we hit the ground, and if we hit W, he jumps way too high in the air. Like a frog, he just goes flying through the air. Let's try 25. That seems like a good compromise. A lot of this is just trial and error. And W. There we go, that's a pretty decent jump. Now I still don't like the speed of gravity. I think it should be a little bit faster. And we should also be applying some damping. Whenever I let go of the W key, it should slow down. So for instance, when I press when I press A to go left, if I let go, he's just going to keep sailing to the left. What we want to do is, since we want to give our players a lot of control, we need to apply some damping that actually slows down the movement of the players, slows down the movement of the player. So let's do that. And let's also give ourselves a max speed. We don't want to let him go as fast as he can, because this apply force to center is going to just keep increasing his speed faster and faster and faster, and that's not what we want at all. Let's change 25 to 21, just to while we're at it. Okay, now we need to apply damping. And to do that, let's actually apply damping up here. What we're going to do is we're going to say else. If he isn't holding A and he isn't holding D, we're going to apply damping. What we're going to do is we're just going to slow down his velocity no matter what. This is sort of like friction. It's really similar, except you can also apply it in midair. And a really easy way to do that is we can just say body arrow set velocity, or set linear velocity. Now we need to create a b2vec2. Now for the x velocity, we're going to apply the damping, and we're not going to apply any damping in the y velocity. So for the x, we're going to say body get, let's see, can we do get x velocity? No, we just got to call get linear velocity dot x times 0.9. So each frame, it's going to be 0.9 times less x velocity if we're not holding A or D. And then in the y direction, we're just going to have, oops, I'm outside of the parenthesis. In the y direction, we're just going to have the same velocity. So body get linear velocity dot y. We're not going to change that one at all. So there's our damping. Let's see what that looks like. I'm going to go ahead and run it. All right, so now when I jump and go left, if I let go, he slows down really fast. That's 0.9. Now 0.9 might be a little too much. Let's do something more like 0.95. Let's see how that one looks. And really, we should also be worrying about time step right now. We're just assuming 60 frames per second. But again, this is the time step and everything and stuff that we've already covered. You guys should be really confident in how to fix that yourselves. So he floats a lot. He's really floaty because gravity is still, I think, way too low. So let's go ahead and modify gravity to be much higher. Let's go into gameplay screen. Let's change gravity. Where is gravity? Here's gravity. Let's change it to be -25 and see how that looks. Okay, now we can still walk left and right, and when I jump, it falls quite a bit faster. Still not quite as fast as I would like. Let's do -40. I'm sure you guys will find much better values that you all prefer. Here we go again. And, ooh, -40 is too much. -40 causes us to actually fly through our ground platform because they're just going much too fast. Now, if we increase the velocity iterations, that would probably fix that. Let's see if we have -30, if -30 works. So it does work, but it still kind of squishes everything in. So I'm going to go with -20. And if you guys want to have a higher velocity, just try increasing the velocity iterations in the actual update function for the world step for step. Alright, so now we can run around and we can jump. We don't have a max speed yet, so let's give ourselves a max speed, because otherwise we can just kind of zoom left and right like a maniac. And let's increase our... I guess we don't need to increase our jump. Jump is decent. Though, if you notice, sometimes we jump twice. If I'm standing near a box and I press W a bunch of times, or even hold W, I can jump higher. That's because we're getting sort of a double jump when we actually collide with two boxes. Since we're touching two boxes here, we're literally jumping twice. That's a small bug that we can easily fix. And to do that, what we need to do is in the player, once we call apply linear impulse, what we should do is we should break out of the for loop. We should stop looping because we only want to jump once anyways. So we're going to call break here. And since we only need below to be true once, we can call break inside this for loop there as well to give us a little bit of a speed boost. Very, very small speed boost. And since we are now jumping much smaller most of the time, let's change this back to 30 and see how that looks. And let's make sure we aren't doing double jumps anymore. So that looks constant sized. If I walk over here, it's not any higher than when I'm standing on top of this. So we fixed that. That looks good. Neat. And I think the acceleration is pretty good, but I think the max speed is much too fast. So let's go ahead and limit ourselves with a max speed. And that's actually very simple. If body get linear velocity dot x is less than, we'll say, let's give ourselves a max speed value. So float max speed equals, we'll say, I honestly don't know. Let's go ahead and go with 0.5 and see what that looks like. And then we can just change it. If it's less than -0.5, then we're going to say body set linear velocity. We got to do this. We'll just copy this. Y doesn't change, but x is going to be, instead of linear velocity.x, it's just going to be negative max speed. And let's go ahead and do else. If body get linear velocity.x is greater than positive max speed, then we do it in the opposite direction. So we copy this, and this will be positive x, and we're missing a comma here. There we go. So now we're limiting our max speed to 0.5, which I have no idea how fast that is, so let's go ahead and see what it looks like. 0.5 is very, very small. As you can see, I cannot move nearly at all. So let's change this to 2.5. That seems like it would be, actually I think 3 maybe makes a bit more sense. Let's try that. So here we go. Jump, go right. 3 is still far too slow. I'm not very good at gauging this. And 7. There we go. So now we have a max speed in the left and right hand directions as well. And we can jump around and we can collide with things, we can push things around. As you can see, this is really, really easy to implement. There's a lot more you can do to make this better. For instance, right now we can't actually walk up kind of curved surfaces very well. Let me see if I can get up here onto this. As you can see, I can't really move up this. I can, but it's kind of tough just because of the way the collision box is shaped. One way to fix that would be to create another little fixture, not just the box, but a circle on the bottom. And having a circle for his feet instead of just the square bottom makes it a lot easier to collide with small objects like this and kind of walk up very small edges. Like I would probably be able to walk up this little lip right here if I had a circle, but I can't since I don't. Now let's see if there's anything else. I don't think so. I'm going to just make the max speed 10 because I think he's going a little too slow still. And I believe in the next tutorial we'll go ahead and work on some 2D animations so we can apply some of our lovely animations to this player so that he actually faces the correct direction and he jumps around and he does punches and kicks and things like that. And as you can probably tell, a game like, for instance, Angry Birds would be really, really simple to build using this physics engine, using Box City Physics. All you would have to do really is to just emulate the basic mechanics, which would take you just a couple nights probably, and then get some art, and then bam, you've got yourself an Angry Birds clone. After you, of course, make all the different levels, which is probably the hardest part. So thanks for watching, everybody. I hope you will stay tuned for the next few tutorials, and very soon we are going to be moving on from this and onto 3D, as well as some Git tutorials and lots of different stuff. There's lots of things for you guys to learn on the horizon. Thanks for watching.